Hello students, welcome back to my channel and this video. In this video we discuss linear Diophantine equation. So linear Diophantine equation we are studying in the modular arithmetic, or it is also a properties of integers. It is coming in number theory. An equation of the form ax plus by is equal to c. Ax plus by is equal to c, where a and b are not equal to 0 and c is an integer, where x and y are unknown variables, is called linear Diophantine equation in two variables x and y. Okay, what is the working procedure to solve this linear Diophantine equation, or what is the general solution for linear Diophantine equation? First you can find the GCD of two numbers a and b. Let us take the GCD of a and b is d. You can find out GCD of a and b is equal to d if this d divides the value of c. If d divides c means, for example, like this: 2 divides 4. 2 divides 4 in the sense 4 can be written as 2 into 2. You can also write 2 divides 12, right? How do you write 12 can be written as? 12 can be written as 2 into 6. So whenever the number divides, you can express in terms of a divisibility. Okay, fine. So you can find the GCD of two numbers, and if d divides c, then it has a solution. If d does not divide, we say that there is no solution for the linear Diophantine equation. Further, if d divides c, you can find a particular solution to linear Diophantine equation. Okay, that is by finding x0, y0 using Euclid's algorithm. You people are already aware that how to find out GCD of two numbers by using Euclid's algorithm, that is by successive division. The last non-zero remainder is called the GCD. So look at, and we need to express in the form of ax plus by. Okay, once you express in the form of ax plus by, then you can write simultaneously the general solution. The general solution is x is equal to x0 minus b by d into m, and y is equal to y0 plus a by d into m is and m is an integer here. Okay, fine. Now let us discuss an example based on linear Diophantine equation. Okay, find the general solution of linear Diophantine equation, that is 39x minus 56y is equal to 11. And student, this example is very simple. First we are comparing this equation with the standard one, that is ax plus by is equal to c. You'll come to know what is the value of a is 39, b is minus 56, and c value is 11. So let us find the GCD of two numbers. Let us first find, step 1 we know very well already. First we are finding the GCD of a and b. What is the GCD of a and b? What is a is equal to 39 and b value is 56. Let us take positive value. Okay, later you can consider b is equal to negative. Okay, while finding the GCD we are taking positive here. So we are using the Euclid's algorithm. I am going to divide this 56 by 39 by successive division. 39 ones are 39, and you can write 16 minus 9 is 7, and this is 17. And you express in terms of division algorithm. 56 can be written as 39 into 1 plus a remainder 17, or every time you are using the division algorithm expressed in terms of a remainder, it is 56 minus 39 into 1. Call it as 1. Next, you can divide this 39 by 17. Okay, fine. So let us divide 39 by 17. 17 twos are 34. The remainder is 5. So directly express the remainder, or you can first write the division algorithm. 39 is equal to 17 twos are plus 5, or 5 is equal to 39 minus 17 into 2. Call it as 2. Next, 17 by 5. 5 3 is a 15. The remainder is 2. Write directly remainder. 2 can be written as 17 minus 5 3s are 15. You can also write before. 17 can be written as 5 3s are 15 plus 2. Call it as 3. Next, 5 by 2. 2 2s are 4. Remainder is 1. And 5 can be written as 2 into 2 plus remainder 1. 1 can be written as 5 minus 2 into 2. Finally, 2 by 1. 1 2s are 2. The remainder is 0. The last non-zero remainder is 1. This is last non-zero remainder. So therefore GCD of 39 and 56 is 1. Okay. GCD is 1, or you can write in a standard form. 39 comma 56 inside the bracket is equal to 1. This one is called a D. Okay. As you know already, what is the second step? The second step is fine. First step is over. The second step is, if D divides C, which implies D means 1, C means 11. Whether 1 divides 11? Yes, definitely 1 divides 11. So therefore, we can say that the given linear Diophantine equation has a solution. Okay, so if it is a solution, then we need to find out a particular solution to a linear Diophantine equation by finding x0 and y0 using Euclid's algorithm. I think we have done Euclid's algorithm, and we try to express in the form of that is 39x plus 56y is equal to some D. What is D value? D is equal to 1 form. So for that, we are going back substitution. Consider the value of, or you can consider the equation number 4. What is equation number 4? 1 is equal to 5 minus 2 into 2. Okay. You can write 1 as it is. What is 5? 5 means you can substitute from equation number 2, which is 39 minus 17 into 2, okay, minus 2 into, substitute the remainder 2. What is the substitute remainder? Which is 17 minus 5 into 3. Either substitute this, because you can substitute any one, okay, either this or this. So only one value by 2. So 1 is equal to 39 minus 17 into 2. You can multiply. This can be written as 17 into 2. Okay. Minus minus plus. Write 5 as it is. 2 3s are 6. Okay. Next. 1 is equal to 39, write as it is, and substitute the value of 17 by using equation number 1. What is 17? 56 minus 39 into 1. I substituted 17 multiplied by 2 minus, or you can write, there are two values of 17, right? 17 into 2, 17 into 2. So you can write, I have substituted 17 value, you can write this is multiplied by 4. Okay, plus what is the value of 5? You can substitute once again 5. 5 is 39 minus 17 into 2 multiplied by 6. Okay, 1 is equal to 39 minus 56 into 4 minus minus plus 39. 1 into 4 is 4. 39 into 6 minus 17 into 2 6 is 12. Okay, now 1 is equal to how many? 13 values. This is at least 13 into 1, 13 into 4, 13 into 6 is, 39 into 1, 39 into 4, 39 into 6 is 39 into 1, 4, 6, which is 11, minus 56 into 4, write as it is. Next, substitute the value of 17 once again. 17 value is 56 minus 39 into 1 multiplied by 12. Okay, now 1 is equal to 39 into 11 minus 56 into 4. You can multiply, minus 56 into 12 minus minus plus, this is 39 into 1 12 is 12, which is, you count 39 values, 39 into 11, 39 into 12 is 39 into 23, again 56 into 4 and 12, minus 56 into 4 minus 56 into 12, which is 16. Okay, fine. So once you get this value, okay, as I told you already that we have to have ax plus by is equal to d. So which is, you can multiply with the c here. It is, you have got ax plus by is equal to d form. This is okay. So now this is in the form of ax plus by is equal to d form, or d is equal to ax plus by. So, or you can write one more step to understand more. This is 39 times of x. Okay, so x can be written as, okay, this is 23 plus 56 times of minus 16. Okay. So this is in this form. Okay. Now finally we have to multiply the value of C. What is the value of C? C is 11. You can multiply both sides. This is 11 is equal to, 39, keep it as it is. You can multiply 11 to 23. 11 into 23 is, which is 253, plus 56 times of 11 into minus 16 is 176. Now this is, you can able to write it as, this is in the form of ax plus by is equal to C, or C is equal to ax plus by. Then x0 value is 253 and y0 value is minus 176. Once you get the value of x0 and y0, particular solution, now you can write the general solution. What is the general solution? General solution is, okay, you get general solution is x is equal to x0 minus b by dm and y is equal to y0 plus a by d into m. Just substitute the value. X is equal to, and m is an integer, x0 is 253 minus b value is minus 56 divided by d value is 1 into m. Similarly, y is equal to y0. Y is equal to, y0 is, this is 176 plus minus 176 plus a value is 39, m divided by d is 1, or finally you can write x is equal to 253 plus 56m and y value is minus 176 plus 39m. So, and m belongs to integer. For different value of m, you will get a solution for the given linear Diophantine equation. That's it. Thank you so much for watching, student. We'll meet in the next video.